Hello friends, the topic for today is 8085 memory interfacing. A memory unit is an integral part of any microcomputer system and its primary purpose is to store programs and data. The primary function of memory interfacing is that the microprocessor should be able to read from and write into a set of semiconductor memory IC chips. In today's video, we will learn the interfacing of static RAM and EPROM to 8085 microprocessor. Let us start. Welcome to our channel Engineering and Technology for You. The topic for today is 8085 memory interfacing. Let us start with the introduction. The memory is made up of semiconductor material used to store programs and data. A typical semiconductor memory IC will have n address pins, m data pins or output pins. Having two power supply pins, one for connecting required supply voltage VCC and the other for connecting ground. The control signals needed for static RAM are chip select, that is chip enable, and read control, that is output enable OE, and write control or write enable WE. The control signals needed for read operation in EPROMs are chip select, that is chip enable, and read control, that is output enable or OE. Now let us see the typical static RAM and EPROM ICs. So the static RAM, here we have the address bus with n, that is the number of address lines which can be connected to the memory, and the outputs, there m, that will be connected to the data bus of 8085. Then we have two signals for the power supply VCC and ground, and these are the signals for the read operation and the write operation. So OE bar, that is output enable, will be connected to read bar, and WE bar, that will be connected to the WR bar, that is write enable, will be connected to write signal, and this is the chip select signal or chip enable signal. So all these signals, they are active low, that's why there is a bubble at this point. They are all active low. And similarly for EPROM, we have the two power supply signals, address bus N and the data bus M, and the chip select CS bar, and there is only one signal for the read operation, that is output enable, that will be connected to the read bar. Then number of address and data pins in memory ICs. So what are the different ICs which are for the RAM and EPROM? So EPROM, the ICs are 2708, 2716, 2732, 2764, then 27256, 27512, then 27010, 27020 and 27040. So these are the IC numbers, and the capacity you can see here, 1 KB to 512 KB. So the capacity and the number of pins, they will be proportional. So 1 KB is nothing but 2 raised to 10, that is 1024. So that is 1 KB. So the number of address pins will be 10 for 1 KB. For 2 KB it will be 11, 4 KB it will be 12, 8 KB 13. Then there is no 16 KB IC available, so directly we go to the 32 KB. So the number of address pins will be 15. Then 64 KB it will be 16. So we already know that 2 raised to 16 is nothing but 64 KB. Then for 128 KB it will be 17, 256 KB it will be 18, and 512 KB it will be 19. And in all the cases, now this memory ICs, they are organized say 1 KB by 8. So that means the number of data pins will be always 8. Similarly, the RAM ICs, they are 6208, 6216, 6232, 6264, then 62256, 62512, 62128, 62138 and 62148. So particularly, now these are the battery backup RAMs. Particularly these ICs are commonly used for interfacing. This 6216, 6232, 6264 and 62256. The capacities are here. Now for 8085, the maximum capacity is 64 KB. So we'll have to use these chips which are below the 64 KB. Then let us go to the next part, that is the steps for memory interface design. The first step is calculate the amount of RAM and ROM. Now here ROM is read-only memory. We are going to use EPROM required for the application. Then select memory devices. That means we'll have to select the ICs which we have just discussed now. So depending on the size or the amount of RAM and ROM, we'll select the devices or ICs. Then draw detailed memory map and address bit map. So this is the step where we'll have to draw the memory map and then the address bit map. Then design address decoding logic. So design of address decoding logic is nothing but with the help of the decoders we'll design this address decoding logic. Then arrange memory devices to have required word length and number of words. So if the word length is 8 bit, then there is no problem, and the number of words, that is the size of the memory, whether it is 8K, 16 KB or 32 KB. So that we have to arrange accordingly. Then draw the interfacing diagram. So at the end we'll have to draw the interfacing diagram. So these are the basic steps for memory interface design. So we'll have to follow these steps whenever you are asked to design the memory interface. Then let us go to the next part, that is types of decoding. So we have two types of decoding, absolute decoding and linear decoding. Now absolute decoding, when all address lines are used in decoding to select any particular location in memory device, that decoding scheme is known as absolute decoding or exhaustive decoding or full decoding. Here all address bits are used in decoding. So that's why it is called as the exhaustive, full decoding or absolute decoding. Then the second type is linear decoding. In this decoding scheme, all the address bits are not used for decoding. So that is just to minimize the circuit this is used. Then let us go and compare these two decoding schemes, absolute decoding and the linear decoding. So this absolute decoding leads to one-to-one mapping, whereas here it will lead to results in one-to-many mapping. That is very important. Then complete address space of the microprocessor is utilized. Then possibility of bus contention is avoided. More hardware is required. Whereas in this case, this leads to one-to-many mapping. Then most of the address space remains unutilized due to creation of foldback. So there will be foldback in this case. And then possibility of bus contention with the empty zone of the address space is there, because some of the pins we are not decoding, then the hardware required will be less. That is only the advantage, otherwise this will create problem. Bus contention and then foldback. These are the two problems, and it will also lead to one-to-many mapping. So we will prefer the absolute decoding for the interfacing. Then next we see the interface of the EPROM and RAM. 64 KB memory space of 8085 is equally divided into EPROM and RAM. So we'll have 32 KB for EPROM and 32 KB for RAM. So implement 32 KB memory capacity of EPROM using single IC 27256. Then 32 KB RAM capacity is implemented using single IC 62256. So we'll be using only two ICs for interfacing. The 32 KB memory requires 15 address lines, and so the address lines A0 to A14 of the processor are connected to 15 address pins of both EPROM and RAM. The unused address line A15 is used for generating the chip select. If A15 is 1, it selects RAM, and if A15 is 0, it selects EPROM. Then these signals read bar, write bar pins of processor are connected to the WE and OE bar pins of the memory respectively. The address range of EPROM will be 0000H to 7FFFH, and that of RAM will be 8000H to FFFFH, that is hexadecimal. Then the interfacing diagram. Then last step we come to the drawing the interfacing diagram. Now here some of the steps we have not covered. That is because here there is no need of much decoding at all. We can directly generate the chip select with the help of single inverter, this NOT gate. So this is the interfacing diagram. This is 8085 and the AD0 to AD7, that is the lower order address data bus. It is connected to the 8-bit latch, and the ALE signal is connected here to the enable signal of the latch. So we'll get the address bus here A0 to A7, and then is 8 to A15. This is added here, and we get A0 to A15. That is 16-bit address bus. Then from this side we get the data bus D0 to D7. So this data bus, they are connected to the both ICs, and the address bus A0 to A14. So 15 signals they are connected here, you can see. Then for the RAM we connect the read bar and write bar, because it requires both the signals, whereas for the EPROM we are connecting only the read bar. It is read only memory, so only it is connected to the OE bar pin of the EPROM. Then from this we are taking this A15 and it is connected here, and this is connected through inverter. So when it is 0, this will be selected, and when it is 1, this IC will be selected, 62256, that is RAM will be selected. So in this way the interfacing will be completed. Then let us take some more examples. Before that we will study the decoder. So here we are going to study two decoders there is 2 to 4 decoder, that is 74LS139, and 3 to 8 decoder 74LS138. So 2 to 4 decoder, it has two inputs A and B and four outputs Y0, Y1, Y2 and Y3. All are active low. So that will be Y0 bar, Y1 bar and so on. So when B and A, when it is 0, 0, then at that time this Y0 bar will go low. So it is active low. And for 0, 1, this Y1 will go low. 1, 0, this Y2 will go low. And 1, 1, this Y3 will go low. So it will decode two inputs into four outputs. Then similarly we have 3 to 8 decoder 74LS138. So it has got three inputs C, B, A, and there are 8 outputs Y0 to Y7, and there are 3 enable signals G2A, G2B, these are active low, and G1 is active high. So when this CBA, they are 0, 0, 0, then Y0 will be, Y0 bar will be low. Then 0, 0, 1, Y1 bar will be low. 0, 1, 0, this Y2 bar will be low. 0, 1, 1, this Y3 bar will be low. Then 1, 0, 0, Y4 bar will be low. 1, 0, 1, Y5 bar will be low. 1, 1, 0, Y6 bar will be low, and 1, 1, 1, this Y7 will be low. So accordingly we can decode the signals with the help of these decoders. Then let us take another example, that is 32 memory space is implemented using 4 number of 8 KB memory. So here the total memory capacity is 32 KB, and again we take 2 number of 8 KB memory for EPROM, that will be 16 KB of EPROM, and remaining 2 numbers for RAM, that will be 16 KB RAM. So already the first step, that is the choice of the ICs, it is given to us. So we are taking 8 KB ICs for EPROM as well as RAM, and each 2 of them. So each 8 KB memory requires 13 address lines, and so the address lines A0 to A12 of the processor are connected to 13 address pins of all the memory ICs. Then here the address lines A13 and A14 can be decoded using 2 to 4 decoder to generate the 4 chips select signals. We'll see how we'll generate that. Then these 4 chip select signals can be used to select one of the 4 memory ICs at any one time. So the address lines A15 is used as enable for the decoder. So here this is the address bit map. You can see the allotment of the address for each memory IC. So first 8 KB EPROM 1. So when we are writing this binary address, so inputs to the address pins of memory IC. Now this is 8 KB. So we are to connect A0 to A12. So first we make all of them as 0, and these remaining lines also we make them 0. So the first address will be 0000H. Then next address will be, this A0 will become 1, so 0001H, and so on. Then what we'll do, whatever inputs are connected to the address pins of the memory IC, we'll make them all 1. So this is 1111, this is 1111, this is 1111. So that is F we get, and here A12 we have made 1, so it will become 1F. Now these 3, they are not connected to the address pins of IC, so they will remain 0 for this IC. Then we go to the next IC. Again, now here what we do, 1FFF. After this, the next address is 2000. So we'll make it 0010. That becomes 2. Then 0000 0000 0000. That is 2000. The next address will be 2001 and so on. Then again we'll have to make all the pins which are input to the address pins of memory IC, that is A0 to A12. We have to make it 1. So we'll make it 1, all these pins as well. So this will be 1 1 1 1 1 1 1 1 1 1 1 1, and we are making A12 as 1. So the address come, and already this is 1. So this will be 0011, that is 3, and then F. So 3FFF. So that will be the last address for the second EPROM. Then we come to the RAM. Again, this 8 KB. So we will be connecting. Now the next address after 3FF will be 4000. So this will become 0100 and then this will be 000. So it will be 4000. Then we will keep this as it is, and now again we will make the last address all ones. So it comes out to be 0101, then 1111 1111 1111 5FFFH. So that will be for the first RAM. Then for the second RAM, now we will make the next address will be 6000. So it will be 0110, that is 6, then 000 6000. So last address will be 0111 and then 1111 1111 1111, that is nothing but 7FFF. So in this way we make the address bitmap and then interfacing. Now when we are drawing the interfacing, we have to make the connections. First arrange all the ICs. So we take the 8 KB EPROM 1, EPROM 2, then 8 KB RAM 1 and 8 KB RAM 2. Particular chips we have taken 2764, 2764, 6264 and 6264. Then we take the 8085. Then again the same operation we have to do. The first is the address data bus 80 to 87, that will be connected to the latch for the demultiplexing of the address and data bus. So the latch will separate, so it will separate this into data bus and the address bus. So with the help of this address latch enable signal, which is used as a enable signal. So A to 15 and this A0 to A7, then combinedly it will be A0 to A15. So out of this we are going to connect 13 lines A0 to A12 to each of the IC. You can see this A0 to A12, they are connected, 13 lines are connected to each IC, and then we connect the data lines to all the IC chips. 8 lines are connected here. Then for EPROM we will be connecting the only the read bar signal to OE bar. Read bar signal is connected to OE bar. Then for RAM, read bar and write bar, both signals are connected here. Then what is remaining is the chip select. So we will connect the remaining lines, that is 3 lines, A13, A14 and A15. Out of this A13 and A14, they are used for the inputs to the of the decoder, and A15 is used for the enable pin. So this A14 is connected to B, A13 is connected to A. So accordingly the first output is connected to the EPROM first chip, the second output Y1 bar is connected to the EPROM second chip, then Y2 bar is connected to the RAM first chip, and Y3 bar is connected to the RAM second chip. So this is how the design will be completed. Then with this we come to the end of this video. If you like the video, press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And if you want to get notifications, press the bell icon. Then if you have any questions or queries, you can contact me on Facebook, Twitter, Gmail or Instagram. Then thanks for watching.